Hey y'all, welcome back to Engineer with Musa. This is Mohammed, and we're gonna be talking in episode 6 about some more statics. And today's lesson actually is gonna be a little bit different. It's not our typical beam that we've been working with. They're actually gonna be doing something like a frame. So I'll just go ahead and paste this problem in here and we'll get started. So the problem statement asks us to find the reaction at the support. The reaction at the support. And here we have a 8 kip load acting in the horizontal direction, 1 kip per foot distributed load, and a 10 kip foot moment acting right over here. So with all that information, we can use our knowledge on static engineering and solve this problem. So first things first is our free body diagram, FBD. And we're gonna go ahead and kind of copy this that we have written and paste it over here for a free body diagram. And make that in green. And then we're gonna first write our external load. So we have an 8 kip foot load over here. And we're gonna take this distributed load and turn it into a point load. So we know that the distribution of this load is 1 kip per foot, and the length of this segment over here, 10 foot. So if we just multiply that, it's gonna be 1 kip per foot times 10 feet. It's gonna be 10 kip acting at the center. So I'll go ahead and do that over here. And we have our external moment over here of 10 kip foot. And we have our reactions down here, which are, I'll call this point A, and this will be point D. This over here will be AY, and that will be AX. This will be DY, and that will be DX. So now if we look at the sum of the moment about point A, sum of the moment equal to 0 about point A, knowing that counterclockwise is positive, we can say that we have -8. Let me go ahead and put the dimension really quickly. So we know that this height is 12 feet. This segment over here is 10 feet and 9 feet. So we have 8 kip times 12 feet minus 100. So that should be 10 kip times 10 feet plus dy times 19 feet minus 10 kip times 14 feet is equal to 0. So we get this last term over here by looking at the 10 kip load over here and then the distance that it's located is at 9 feet plus half of this, which is 5. So 9 plus 5 is 14 feet, and that's where we get this 14 from. And the 10 over here comes from this 10 kip load. So hopefully that makes sense. Now we can solve for dy, and we'll find that equals to 17.68 kips. And then we're going to look at the sum of the forces in the y direction, where up is positive, equal to 0. And we'll say that, by the way, this is in a 3, 4, 5 configuration. And we can find that 4/5 of RA plus 17.68 minus 10 is equal to 0. So this 4/5 over here came from so actually this reaction over here. So the vertical component of this reaction is 4/5. And then this came from over here, and then the minus 10 came from over here. Cool. Then we get that RA is equal to 9.60 kip. And last, we can do sum of the forces in the x direction equal to 0. And we'll find that we have 3/5 of the RA. So we're looking at this portion right here, 3/5. Plus dx, which comes from here. Actually, it's going to be minus dx in this case. Minus dx plus 8 is equal to 0. Then we have minus 3/5 RA which is 9.60 kip minus dx plus 8 is equal to 0, therefore dx is equal to 2.63 minus 2.636 kip. And since the value is negative, we know that it is going to be in the opposite direction that we draw on this. So that means that it's actually dx equal to 2.636 kip in that direction. So opposite of what we drew. So hopefully that makes sense, and hope you enjoyed.